Hello and welcome to Godsmarts. I'm Keith Campbell, independent priest of the Home Temple. Now, last time we started a series on young earth creationism versus evolution. We saw that some Christians have set up young earth creationism as a sort of litmus test of Christianity, even though the evidence clearly shows that the cosmos itself is very old. Either that or God pulled some fancy rabbits out of his hat to convince us otherwise. And we saw that the book of Job suggested a plan to follow if we aren't sure about the facts of creation. But now ask the animals and they will teach you, or the birds of the sky and they will tell you, or speak to the earth and it will teach you, or let the fish of the sea declare it to you. Now, let's do as Job suggests and ask the earth about its age. Well, it turns out the earth is a lot younger than the universe itself. The earth is only about 4.5 billion years old. Now, that's not a guess, that's not a hypothesis, that's a measurement. We can start with annual measurements of things like ice, for example. The earth has places where ice has been accumulating in annual layers like tree rings for about 150,000 years. Now, already this is much longer than the biblical age of 6,000 years. Ice does not accumulate in these patterns if it's just dumped all at one time. We can count the annual layers of sediment near some of the oldest rivers and lakes. The layers of the Green River Formation go back at least 6 million years. Again, massive flooding doesn't explain these annual layers. But if we want to go back to the very beginning, we need to study radioactive decay. Now, hopefully we're all familiar with basic atomic structure. The core of an atom contains protons with a positive charge and neutrons with no charge. The basic carbon atom, for example, has 6 protons and 6 neutrons, usually. Sometimes, however, carbon can have something called isotopes, and isotopes are different versions of the main chemical with different numbers of neutrons, which don't affect the chemistry of carbon except to make it just a bit heavier. But often, these isotopes can throw off their extra neutrons, turning back into simpler versions of the element. And this will happen at a particular rate or speed called a half-life. If you take a pure bar of the original isotope and wait for one half-life, you will find that half of the original isotope is gone, replaced by its daughter isotopes. Wait another half-life, and half of the half will be gone, leaving a quarter. Another half-life, and you'll have an eighth left, etc. Now, some elements have very short half-lives that are not much use to us in dating rocks. Others, like potassium, for example, have much longer half-lives in the billions of years. And the really cool thing is that it looks like almost nothing can significantly alter the half-life of an element, making it ideal as a clock. Furthermore, if we use isochron dating, then any question about the original amount of isotope present disappears. For example, we take a typical rock and we break it down. We end up with many different crystals, and some of these better incorporate one of the daughter isotopes, and some of them prefer the parent isotopes. So if we mapped these minerals out on the day the rock was created, it would look something like this. But if we look at the rock now, we'll see something like this, where the minerals that had more of the parent isotope now have a larger increase in the daughter isotope. Because the samples seem to fit a straight line, we can see that the geological process was constant, with no leaking of materials. So, using these dating methods, what are the ages of the oldest materials on Earth? Here are a number of results that were taken on rocks in Greenland. They all hover near 3.6 billion years in age. First, a rubidium-strontium isochron gives us an age for the Earth of 3.7 billion years. Then, a lutetium-hafnium isochron gives us an age for the Earth of 3.55 plus or minus 0.2. Next, dating the uranium into a lead isotope gives us a 3.65 billion year age. And then a thorium-lead isotope dating gives us 3.65 billion years. And finally, a study of one lead isotope decaying into a different one gives us a date of 3.8 billion years. Do we have any idea how much evidence God would have to fabricate to make the Earth appear this old? He would not only have to mess with one half-life, but the half-lives of all of these different elements, and yet still make them all match the wrong number. Why? Anyhow, we don't know from these studies exactly how old the Earth is, because it looks like the Earth spent the first part of its history as an active volcanic surface, and that resets the clock. But what about the age of meteorites? These meteorites are chunks of rock that have been floating around in space until falling down to Earth. Presumably, these are bits of the same cloud of particles from which the original Earth was made. And, sure enough, the ages of these meteorites seem to be a good billion years earlier. This represents the billion years when the Earth was still an active volcanic mass. So there you have it. And if we measure the age of the Earth, it's 3.6 billion years, and the Earth appears to be part of a mass of stuff that's about 4.6 billion years old. What's the alternative to this? Again, it's God sneaking in special decay rates virtually everywhere, specifically to deceive us into thinking the Earth is 3.6 billion years old when it's actually only 6,000. Or changing the decay rates, or who knows. So that's what happens when you do as Job suggests and ask the Earth a little bit about how old it is. Next time we're going to talk a little bit about life, what it is, where it comes from, and how it got there. Until next time, I'm Keith Campbell. See you soon.